Hello everyone, welcome to the channel StatisticaHub. So in the previous lectures we have done till question number 18 and now we'll do question number 19. Okay, so let's see it. What is in it? The volume of the region R is equals to x square plus y square less than equals to 4. Okay, so by seeing that equation I can see that this is a equation of circle, that is x square plus y square less than equals to r square. So here the radius of the circle is 2. Okay, so this is the information that I got from this, and the limit for z is 0 to 4 minus y, and I have to find the volume of this region. Okay, so for finding the volume of this region, we will do in the triple integration dz dy dx. Okay, so what is the limit for z is going from 0 to 4 minus y. Okay, and y is going from, I can write this as y is going from plus minus 0 to 4 minus x square by using this equation. Okay, so y is going from minus 4 minus x square to root of 4 minus x square. Okay, and the x will go from minus 2 to 2, as the radius is 2, so it will go from minus 2 to 2. Okay, now let's see it. So I have this triple integration. Now this will be 4 minus y dy dx. Okay, now we can separate this like integration 4 dy dx minus integration y dy dx. Okay, that is equals to, now this will go to 0. Okay, how? You can see that as the limit for y is minus root 4 minus x square to root of 4 minus x square. Okay, so if we solve this, this will be y square by 2 minus root 4 minus x square to root of 4 minus x square dx. Okay, by substituting the values, we will got 4 minus x square by 2 minus 4 minus x square by 2. That will cancel out and this integration will go to 0. Okay, so the remaining integration that we have is 4 double integration dy dx. Okay, now look at this double integration dy dx. What is this? Double integration dy dx. This is the area of circle. Area of circle. And what is the area of circle? That is pi r square. And what is the radius here? The radius that I got is 2. Okay, so I have 4 of pi r square, 2 square. So I got 4 for the 16, that is 16 pi. The volume of this region is 16 pi. That is option number C. Okay, so the thing is that if you didn't know that this is the area of circle, then what you have to do is you have to just solve the triple integration, just go by the integration terms. Okay, just solve this integration and you will also get 16 pi. But I think just you have to apply this integration formula, that is root a square minus x square, and if you apply this formula, that is x by 2 root a square minus x square plus a square by 2 sine inverse x by a. Okay, if you solve this triple integration, if you didn't know that this is the area of the circle, then you have to just solve this integration by applying this formula. You have to apply this formula once, and by substituting the values of minus 2 to the limit of this minus 2 to 2, you will get your result, that is 16 pi. Okay, just do it on your own, and if you didn't get this, then you can just put it on the comment section. Okay, now let's see another question. Question number 20. Okay. So it is saying that for real constants alpha and beta, suppose that the system of linear equations, these are the corresponding system of linear equation, has infinitely many solutions. Okay, it has infinitely many solutions, and then the value of 4 alpha plus 3 beta. So what do we have to do is we have to find the values for the alpha and beta, given this that given the information is that the system of linear equations is has infinitely many solutions. Okay, so I can just convert the system of linear equations into an augmented matrix form, right? Let's just convert this into an augmented matrix form, that is 1 1 0 2 1 2 3 alpha 1 and 6 3 beta. Okay, where this is my A matrix and this is B's, and the corresponding augmented matrix is AB. I can write it like this. Okay, now let's just apply transformations on this. Let's apply R2 to on R2 minus R1. Okay, and let's see the result. 1 2 3 6, and this is 1 minus 1 0 minus 1 alpha minus 3, uh, and this will be minus 3, right? Minus 3 and 0 2 1 beta. Okay, now apply further transformation on R3, that is R3 plus 2R2, and after this we will got 1 2 3 6 0 minus 1 alpha minus 3 minus 3 0 0 2 alpha minus 5 and beta minus 6. Okay, so this is the this is the matrix after transformation. Okay, now we know that for infinitely many solution, for a matrix to have infinitely many solution, the rank of augmented matrix is equals to the rank of the matrix A, and this is less than 3, that is number of rows or columns in like minimum of number of rows of columns. Okay, so that has to be less than 3. Okay, okay, so and we know that for this term has to be 0, 2 alpha minus 5 has to be equals to 0, and beta minus 6 has to be equals to 0 by applying this infinitely many solutions tactic. Okay, so we got 2 alpha equals to 5, that is alpha equals to 5 by 2, and beta equals to 6. And what do we have to find? We have to find 4 alpha plus 3 beta, that is equals to 4 into 5 by 2 plus 18. Okay, that is 2 to the 4, 5 to the 10, and this is 28. Okay, so our result is option number C, that is 28. Okay, so it was a pretty easy question. You can do that very easily. You just have to know that what are infinitely many solutions tactic. Okay, now let's see question number 21. What's in this? So it is saying that let x, y, z be a random vector having the joint probability density function f x, y, z equals to 1 upon 2xy, 1 upon 2x square, and this is the limit for this, that is 0 less than z less than y less than x less than 1, and this is when if 0 less than z less than x less than y less than 2x less than 2. Okay, then which one of the following statement is false? Okay, so we have to find that which one of the following is false. Okay, see this is when all the values of z, y, x are lying between 0 to 1. And similarly here, as if I simplify this one, this is basically x is less than 1. So here also all the values of z, x and y are lying between 0 to 1. Okay, now see this. Okay, look at this one. It is saying that probability of x less than y less than z. Okay, so let's find out this case, that in which case this is the inequality x less than y less than z is present. Okay, so here it is z less than y less than x. It's not this one. It doesn't lie in this region. Here it is x less than y less than 2x, and z less than x less than y. Okay, so it doesn't lie in this region. So x less than y less than z lies in this third region, that is otherwise. So the probability of this x less than y less than z, as it doesn't lie in these two regions, it will lie in the otherwise region, so the probability will be 0. Okay, right? So this is the true statement. Okay, now let's look at this one, that probability of z less than y less than x. Okay, now in this region, in which region this one lies? I think it is the very first region, that is if 1 upon 2xy, if 0 less than z less than y less than x less than 1. Okay, so this is the region where this region is, this is lying. Okay, so let's just find out its probability. Okay, this is integration, triple integration, that is 1 upon 2xy dz dy dx. Okay, what is the limit for z? Depending limit for z, not limit for z, depending limit for z, that is 0 to y. Okay, the depending limit for y is 0 to x, and what is the limit for x? That is 0 to 1. Okay. So if I just find out the probability of this one, this will be 0 to 1, 0 to x, and this is y upon 2xy dy dx. Okay, y will cancel out, and this will be 0 to 1, 0 to x, 1 upon 2x dy dx, and this will further be equals to 0 to 1 x upon 2x dy, sorry, dx. Okay, and this will cancel out. This is equals to 0 to 1, 1 by 2 dx, and that is equals to 0 to 1, sorry, x 1 by 2, 0 to 1. Okay, so it will be equals to 1 by 2. Okay, so we got the probability of z less than y less than x is equals to 1 by 2. Okay, so this statement is also true. The two statements that we got, this option C and D are correct options, and we have to get that the one which is false. Okay, so in from both of these there is one option which is incorrect. Okay, now let's just clear the page. Okay, so let's look at this option, that is variance of y given x is equals to 1 by 2 equals to 1 by 12, whether this one is correct or not. Okay, so let's see this one. So for finding this variance of y given x, the conditional probability of y given x, we have to find the joint distribution of x and y. Okay, so basically we have to find f y given x. Okay, that is distribution of y given x. And for finding this, we know that we have to find f of x comma y, that is joint of x and y, and the marginal of x. Okay, we have to find these two things for finding the variance of y given x is equals to 1 by 2. Okay, so let's just work on the marginal of x first. Okay. Okay. So let's say I'm naming this as first region and I'm naming this as second region. So you don't get confused. Okay. So let's just find very f of x for my first region. Okay. What is my marginal of x for first region? That is, for finding the marginal of x for the first region, I have to put all the values of like dz, dy. Okay, all the limits of z and y. Okay, that is 1 upon 2xy. What is the limit for z? That is 0 to y, and the limit for y is 0 to x. Okay, we always put the dependent limits. For the z, it is 0 to y, and for the x, for the y, it is 0 to x. Okay, let's just solve this. This will be 0 to x, y upon 2xy dy, that is equals to 0 to x 1 upon 2x dy. Okay, and that is equals to 1 upon 2. 1 upon 2. So I got my marginal distribution of x is equals to 1 by 2 for x lying between 0 to 1 for the very first region. Okay, look at this very carefully. This is for the very first region. Okay, now let's find this marginal of x for second region. That is fxx for the second region. What will that be? 1 upon 2x square dz dy, and what is the limit for z? The depending limit for z here is 0 to x. Okay, and what is the depending limit for y? That is x, so x to 2x. Okay, x to 2x, and that is equals to uh okay, x to 2x and x upon 2x square dy. I'm just integrating these, nothing doing that much. X upon 2x, 1 upon 2x dy. Okay, and this will be equals to 1 upon 2x y, putting limit x to 2x, that is 2x minus x, and that will be x. So I will got x upon 2x, that is equals to 1 by 2. Okay, so what did I get? I got my fxx. Okay, for the region 0 to 1, as all these three things, that is x, y, z, in both the regions are lying between 0 to 1. They are lying between 0 to 1. Okay, so the marginal of these both is 1 by 2 and lying between 0 to 1. Okay, so can I erase this page? I can just erase it because we have to do find a joint distribution of x and y. Okay. Okay. Okay, so what is the marginal of x? We got marginal of x fxx, that is equals to 1 by 2 for both, that is for 0 less than x less than 1. Okay, for both the regions, for both regions. Okay, now let's find out f of x comma y, that is joint of x comma y for the very first region, that is f of x comma y. Okay, f of x comma y, what will be that? We have to put the depending limit for z. Okay, for finding the joint distribution of x and y, that is 1 upon 2xy dz. What is the depending limit for z? That is 0 to y here. 0 to y, that is equals to y upon 2xy, which is 1 upon 2x. Here, what is the limit for this one, this region? That is 0 less than y less than x less than 1. This is the region for f of x comma y, right? As we have put it the depending limit for the z, so the region will be this now for this f of x comma y. So what is the region? Let's find out for the second region, f of x comma y, that is depending limit of z 1 upon 2x square. And what is the depending limit for z in this region? 0 to x, right? 0 to x, and that is equals to x upon 2x square, that is equals to 1 by 2x. And the limit for x, this joint distribution of x and y here is 0 less than x less than y less than 2x less than 2, right? So what did we get here is, look at this very carefully, we got f of y given x. Okay, so if you look at it very carefully, then the f of the joint for first region is 1 by 2x and the joint for second region is also 1 by 2x. Similarly, the marginal for both of these region is 1 by 2. So if I found out f of y given x, that is basically f of x comma y upon f of x, that will be equals to 1 upon 2x upon 1 by 2, that is equals to 1 by x. Okay, for the regions, for two different regions, that is 0 less than x less than 0 less than y less than x less than 1, and for the other region, that is 0 less than x less than y less than 2x less than 2. Okay, so this is the distribution that I got. Okay, now look at it. Look at this very carefully. This is fy given x is equals to 1 by x for the first region, that is 0 less than y less than x less than 1, and the second region, that is 0 less than x less than y less than 2x less than 2. Okay, now I am looking at like that this is following uniform 0 comma x. Okay, and this second region is following uniform 2x comma 2. How? Because if you find the PDF of this one, this will be 1 by x and the limit for y here is 0 to x. Okay, similarly for the limit for y here is x to x, and if you find the PDF of this according to the uniform, this is actually x comma 2x, sorry. Okay, x comma 2x, then it will be, what is the PDF for uniform, that is 1 upon b minus a if x is going from b to a. Okay, that is f of x is 1 upon b minus a in the uniform. So if it is going from uniform 0 to x, then it will be 1 upon x minus 0 0, 1 upon x minus 0 1 by x. Okay, similarly 1 upon 2x minus x, that is equals to 1 by x. Okay, so by applying this, we got the uniform distribution, that is 0 comma x for the first region and 0 x comma 2x for the second region. Okay, now in the uniform case, we know that uniform is a continuous distribution. Okay, uniform is a continuous distribution. So I am getting for the region 1, the uniform is 0 comma x, and for the region 2nd, I got my distribution fy given x is following uniform x comma 2x. Okay, that are basically, we have to find the variance of x. Okay, we have to find the variance of y given x is equals to 8x is equals to 1 by 2. Okay, so let's just put x is equals to 1 by 2. Okay, if we put x is equals to 1 by 2, this will be 0 comma 1 by 2, and this will be 0 comma uniform 1 by 2 comma 1, right? And uniform is a continuous distribution, so we can just definitely combine them, and this will follow uniform 0 comma 1. That is, it is going from 0 comma 1 by 2, and this second one is going from 1 by 2 to 1. And we know that uniform doesn't, it is a continuous distribution, so it doesn't depend on the point. Okay, the PDF is actually not depend on the point, it is a continuous distribution. So because of this, because of its continuity, we can combine these two region, and this will combinedly follow uniform 0 comma 1 distribution. Okay, so we got that f of y given x is following uniform 0 comma 1 distribution. Okay, f of y given x is following uniform 0 comma 1 distribution. Now what do we have to find? We have to find variance of y given x. Variance of y given x is equals to 1 by 2. We have already put it x is equals to 1 by 2, right? And variance of y given x, what is the uniform's variance? That is, variance of this y given x is equals to b minus a's whole square upon 12. And what is a and b? A and b is actually 1, b is 1, and a is 0, as it is following uniform 0 comma 1. So the variance will be here is 1 by 12. Okay, so we got variance of y given x is equals to 1 by 2 equals to 1 by 12. Okay, so from this we can say that our corresponding third option is like second option is also correct. Okay, so our three options are correct, so we know that the first one has to be false for this question to be satisfied. Okay, so we know that this first one option is false, but let's just verify it by doing some calculation. Okay, so what is it asking? It is asking that expectation of minimum of x comma y. Okay, what will be the expectation of minimum of x comma y? Okay, mm, let's just erase it first. Okay, so if it is saying that expectation of minimum of x comma y, then minimum of x comma y is basically that one time we can say that x is less than y, and the other time we can say that y is less than x. Okay, so these are the two possible cases that can be found in this minimum of x comma y. Okay, that is minimum of x comma y. Okay, minimum of x comma y, if you look at these two regions, then here y is less than x, and here it is x is less than y. Okay, so if the two cases that are formed here is whether x is less than y or whether y is less than x, these are the two possible cases that has to be formed in this minimum cases. Okay, so if minimum of x comma y is equals to y, then it will be for this region 0 less than z less than y less than x less than 1. Okay, it will be for this region. Okay, so as we are talking about this f of x comma y, as it is the joint of f of x comma y. What is the joint of x comma y? F of x comma y, that is 1 by 2x for two regions, that is 0 less than y less than x less than 1, and another region that is 0 less than x less than y less than 2x less than 2. Okay, so minimum of x comma y, if y is minimum in these two cases, if y is less than x, y is less than x, then it will lie in this first region. Okay, that is 0 less than y less than x less than 1, this is corresponding first region. If in these cases, if x is less than y, if x is less than y, that is minimum of x comma y, in these two x is the minimum one, then it will lie for the region 0 less than x less than y less than 2 x less than 2. It will lie in the second region, right? Then what do we have to do? Find, we have to find the expectation of minimum of x comma y. So we have got this, that minimum of x comma y is equals to y, that the minimum will be y if for 0 less than y less than x less than 1, and it will be x for the second region, that is 0 less than x less than y less than 2x less than 2. Okay, because it is clearly stated in the inequality that y is less than x and x is less than y. Okay, okay, so let's just find out this f of y, distribution function of y, that is f of, it is actually f of minimum of x comma y, and we are taking it very for the very first region. This is my first region and this is lying in the second region. So we are finding f of minimum of x comma y, and minimum of x comma y for the first region is y, so we are finding f of y. Okay, what is the distribution of f of y? So f of y, as y is lying for the first region is 0 to, Okay, so for finding the minimum of y, like distribution function of y, we have to put the dependent limit of x. Okay, 1 upon 2x. Okay, so we got f of x comma y, that is the joint distribution of x comma y, is 1 by 2x for these both limits. Okay, so we will use this joint distribution. Okay, and 1 by 2x into dx, what is the dependent limit for the x, that is 1 y to 1. Okay, and that will be equals to 1 by 2 log x 1 to y, and by putting the values we got 1 by 2 log 1 is 0 and minus of log y. Okay, so we got minus 1 by 2 log y. Okay, now we have to find the expectation of y. What is expectation of y? That is minus k 1 by 2, and y will go lie from 0 to 1. Okay, y will lie from 0 to 1. Hey, from this you can see that. Okay, this fy 0 less than y less than 1 is for this region. Okay, 0 to 1 y log y dy is equals to minus k 1 by 2 uh, log y minus y square by 2. Just apply this integration first into second formula for the integration, minus 1 by y into y square by 2, 0 to 1. I am considering this is as first and this is my second. Okay, just apply this integration, and that will be minus 1 by 2 log y, sorry, this is into log y into y square by 2 minus, and this will be y square, this will cancel out, this will y square by 4, 0 to 1. Okay, let's just put the limits, that is 1, that will be equals to minus 1 by 2, 0 minus 1 by 4. Okay, and this is equals to 1 by 8. Okay, so I got expectation of y is equals to 1 by 8. Okay, and okay, let's just remember it that expectation of y is 1 by 8. Okay, now we have to find this similarly for the second region, that is minimum of x comma y when the minimum of x comma y is x. Okay, okay, let's just find it for the second region. Then it is actually, so we know that f of minimum of x comma y for the second region, that is f of x is equals to, for the second region, what is the depending limit for this one? For y, it is x to 2, 1 by 2x dx, that is equals to 2 minus x by 2x. And what is the expectation of x? If I found the expectation of x, then x is also lying from 0 to 1, 0 to 1, and this will be 2 minus x by 2x dx. Okay, 2 minus x by 2x dx, that is equals to, oh, what is the PDF of this one? This is 2 minus x by 2x. Oh, actually, a minute. Okay, sorry. So it is actually x to 2x. Sorry, it is going from x to 2x, right? So we have done similar, like silly mistake. That is, y is lying between x to 2x, that is 1 by 2x. So it will be actually x by 2x. 2x minus x by 2x, that is equals to 1 by 2. Okay, we have found out the marginal of x. It is basically the marginal of x, that is equals to 1 by 2 for x lying between 0 to 1. Okay, so the expectation of x here will be x into, okay, that is 0 to 1 x into 1 by 2 dx, that is equals to 1 by 2 into x square, uh 1 by 2 x into 1 by 2 x square by 2. Okay, putting the limit 0 to 1, that is 1 by 4. Okay, so we got, what did we get? We get expectation of x is equals to 1 by 4. Okay, so now let's look at it. Okay, so we got two expectations. Okay, let's just write it very in a very clear format. Okay, so we have to find expectation of minimum of x comma y. Okay, and there are two possibilities for that, that if x is less than y, okay, and if y is less than x, okay. So and we got see this, that if y is less than x, then it is lying in the first region, and if x is less than y, then it is lying in the second region, okay. So in the second region we have to find, basically we have to find expectation of x, okay, that is if x is less than y, and in the second first region we have to basically find expectation of y, because y is less than x, okay, minimum of x comma y. So we got expectation of x is equals to 1 by 4 and expectation of y is equals to 1 by 8, okay. Now we can see that 1 by 8 is less than 1 by 4, okay, 1 by 8 is less than 1 by 4. So by applying this inequality which says that expectation of minimum of x comma y is less than equals to minimum of expectation of x comma expectation of y, okay, you can also check it by like this, which is less than equals to minimum of expectation of x, that is minimum of expectation of x, that is 1 by 4, comma 1 by expectation of y, that is 1 by 8, okay, and the minimum in these two is 1 by 8, okay. So the expectation of this minimum of x comma y has to be less than 1 by 8, okay, it has to be less than 1 by 8, okay. You can also check it by this inequality, and this is greater than 1 by 8, okay. So this is the false statement, this is the false statement, because we got two expectations for two different regions, that is 1 by 4 and 1 by 8, and the minimum expectation is less, the minimum expectation is 1 by 8 for the first region, y is less than x. So my expectation of minimum of x comma y by this inequality 2 has to be less than equals to 1 by 8, okay. So we got that my first option is correct, that it is the false statement in all, okay. So this question is actually like, you have to apply all the concepts here, you have to apply conditional probability, you have to be very careful with the limits, okay. Actually we while doing this question I got stuck into this uh, while applying this f of x, okay. So you just have to be very careful while applying the limits, that what limits you have to put in this question, okay. Okay, so it's all about question number 21, okay. Now let's see question number 22, what is in this. So it is saying that let x and y be jointly distributed random variables such that for every fixed lambda greater than 0, the conditional distribution of x given y equals to lambda. It is saying that conditional distribution of x given y equals to lambda is the Poisson distribution with the mean lambda. Okay, it is following Poisson lambda if the distribution of y is following gamma 2 comma 1 by 2, gamma 2 comma 1 by 2, then find the value of probability x equals to 0 and probability x equals to 1. Okay, let's find that. So we know that f of x given y is equals to f of x comma y upon f y y. Okay, so we'll just apply very simple thing, that is f of x comma y is equals to f x given y into f y y, and we know the distribution of y, we know the distribution, conditional distribution of x given y. We'll just put these formulas and we'll got our joint distribution of x and y, okay, and we'll find the marginal of x by this joint distribution of x and y, okay. We are going to apply these things in this, okay. Now look at this, I can write it like this, one is x given y equals to y following Poisson y, okay. This will be easy in the calculation part because you will not get misunderstood, okay. Let's see it. So my f of x comma y is equals to what is x given y, it is following Poisson with y, okay. This is e is power minus y is power x upon factorial x, okay. And what will be the gamma distributions pdf, okay. We are applying f of x comma y is equals to 1 upon a is power lambda e is power minus of x minus a minus x by a x is power lambda minus 1 upon gamma lambda, okay. And my a here is 1 by 2, so the pdf here will be a is equals to 1 by 2 here, okay. So my pdf will be here is 4 into like 2 square, 2 square e is power minus 2y, y is power 2 minus 1 upon gamma 2. Okay, now we know that gamma 2 will be equals to 1. Okay, and y's power 2 minus 1 is equals to y. So this equation will be 2's power 2 is equals to 4. That is 4 y's power this, and this will form x plus 1 e's power minus 3y. This is okay. By adding these, this will be e's power minus 3y upon factorial x. Okay, and gamma 2 will be 1. Okay, now we'll just find the marginal of x. As we know that we'll put the limit for y, and y is following the gamma distribution, and the limit for gamma distribution is 0 to infinity, and we'll put it here, that is 4 upon factorial x y is power x plus 1 is power minus 3y into dy. Okay, we are putting the limits here, and we are finding the marginal of x, and this will be 4 upon factorial x 0 to infinity y is power x plus 1 is power minus 3y into dy. Okay, now I want to apply this gamma function here, that is e is power minus 3y is power minus ax y is power x plus 2 minus 1. I can write it like this, and this will form 4 upon factorial x uh, gamma x plus 2 upon 3 is power x plus 2. Okay, and from this we will get 4 upon factorial of x, and this will be factorial x plus 1 upon 3 is power x plus 2. Okay, and this fxx is equals to, this will be 4x plus 1, right? 4x plus 1. Okay, because this will cancel out, 4 factorial x can cancel out, 4x plus 1 upon 3's power x plus 2. Okay, now we have to find the probability at x equals to 0 and at x equals to 1. Okay, so for finding a probability at x equals to 0, we'll put x is equals to 0 in this. That will be 4 0 plus 1 upon 3 is 0 plus 2. That is equals to 4 upon 3 square. Okay, so we got 4 by 9. And what is the probability of for x equals to 1? Putting x equals to 1 in this f of x, that will be 4, 2 upon 3's power 3. Okay, that is 4 to 8 and 27. Okay, now we have to add these two probabilities, that is 4 by 9 plus 8 by 27, because we have to find the sum of these two probabilities at x equals to 0 and at x equals to 1, and that will be equals to 27 12 8, that is equals to 20 by 27. Okay, okay, let's see whether this is in the option or not. Okay, so this is my option number B. Okay, 20 by 27. Okay, so this was a medium question, like it was an easy question. Okay, okay, so just remind the concepts that you have to apply, and they will be very easy for you. Okay, so this is all about the question number 19 to 22. Okay, let's meet in another lecture. Thank you.